Okay, in our journey of solving quadratic equations, we started out with factoring, ran into some problems with factoring, that there were some quadratics that were not factorable. So then we discovered the method of completing the square, and completing the square works really nice when our leading coefficient is 1, and the linear term b happens to be an even number. But the issue there, what happens when b is an odd number? We end up doing a lot of fractions. So then we figured, is there an easier way to solve quadratics? Or in other words, is there an end-all be-all formula that will solve every quadratic out there? And that's where the quadratic formula is coming from. So for any quadratic function or equation, if we'd like to solve it in the form of ax squared plus bx plus c, we can figure out what those x values are by plugging in all the information into the formula here below. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can find the numbers for a, b, and c by looking at the quadratic above in that form. But what you need to understand that is not every quadratic is going to have an a, b, and c visible to you. If the b or the c is missing, then you're going to use a 0 for that particular letter. Okay? B and c could both be missing at the same time. The only letter you don't have to worry about being missing is the letter A. If the letter A is gone, then it would not be a quadratic. We wouldn't be talking about solving the quadratic formula. So if we got an A there, we'll see that there are two A's in the formula, so we'll be putting them in those numbers in twice. The number B will be in the formula twice as well. You'll see that there's a negative with the B. I like to think of the negative sign as the word opposite. So if the number is, say, a positive 2 in the quadratic, I'm going to use negative 2. If it happens to be a negative 5 in the quadratic, then I'll be putting positive 5. I'm always doing the opposite of the sign. And then the last letter, the constant c, is only in the formula one time. But in this video, we're just going to focus mainly on the discriminant. Now, what is the discriminant? The discriminant is the part that's underneath the square root. That's the b squared minus the 4ac. So once again, we can take those a, b's, and c's, and we can plug it in for the respective letters there and see what that number value is. However, one thing you've got to be careful with, it is extremely important that all of your quadratic equations that you're trying to solve for are set equal to 0, and at the same time that they're in that standard form. They have to go in order from ax squared to bx to c. They can't have the terms out of alignment, otherwise you'll not be plugging in the correct numbers. So let's build on this idea of this discriminant. There are three values of numbers that we can get. Either our discriminant could be greater than 0. So what do I mean by being greater than 0? All I'm talking about is if that number is positive, we know for a fact that we're going to have two real answers. Now, is that number, that discriminant number, could it possibly be a perfect square? Could it be like the number 4? Could it be 9? Could it be 25? And so on, those types of numbers. If that positive number happens to be a perfect square, what we're going to say is that it has two real rational roots, that we'll be able to write our answers as fractions. If that number happens to not be a perfect square, then we're going to change our wording up slightly. We're going to say that it has two real irrational roots. We're not able to write this number as a fraction. We're going to have radicals and such in there. Okay, so what happens if our number is not positive? Well, the other possibilities is, well, what if our discriminant happens to be 0 itself? If that happens, then we're going to say that it has one real rational root. There's only one solution. And if I back up a little bit, you'll see here that there's a visual picture that goes with these discriminants. If it was positive, then we see that it's going to hit the x-axis twice. That's why it's got the two real roots. If it's 0, then it's only going to touch the x-axis. So that's why we only got one real root. And then finally, the last possibility, if b squared happens to be less than 4ac, then that means the number is negative. And we're taking square roots of negative numbers. And if you can remember back from the last chapter, we broke down some radicals that had negative numbers under there. That's where the I came from. So we will say that it has two complex roots. These are pictures of graphs that do not touch the x-axis. So without further ado, let's look at some examples of finding the value of the discriminant and what type of root we will have. Here in example A, we have 7x squared minus 11x plus 5. Let's first identify what's the a, b, and the c. Well, first, the a is the number that's in front of x squared, so I just want to borrow the 7. b is going to be the number in front of x, so that's negative 11. And finally, c is going to be 5. we're going to take all those numbers and we're going to plug it into that b squared minus 4ac formula. So as I plug it in, notice that I put the negative 11 in parentheses because that's going to matter when I use the calculator. Squaring a number is always positive. So when I square negative 11, I'm going to get 121. Multiply negative 4 times 7 and 5, that gives us negative 140. But the value of that is negative 19. But the more important thing is that number is negative. That tells us what types of roots we're going to have. And if you can think back, just a second ago I said if our discriminant happens to be negative, we're going to have two complex roots. So if we continue with the quadratic formula here, we're going to have i's in our answer. Let's look at another example. First, again, let's identify the a, b, and the c. You might see the x squared, there's not a visible number there, so remember that's just a 1. So our a is the value of 1. B is going to be 22, and c is 121. So again, plug it into b squared minus 4ac. That gives us 22 squared minus 4 times 1 times 121, which gives us 484 minus 484, and that's absolute 0. So since our discriminant is 0, we know that we're only going to have one real rational root for this problem. One last example in this video. Third time, identify the a, that is a negative 5, that's the number in front of x squared. B would be the number in front of x, 8. And c is negative 1, and once again, plug it into b squared minus 4ac. Get 8 squared minus 4 times negative 5 times negative 1, which will give us 64 minus 20, which is the value of 44. Now, you might wonder, is that going to be in that realm of, is it two real rational roots? Is it two real irrational roots? Well, we could type this number, 44, into our calculator and see, will it give me a decimal or does it give me a nice whole number? Turns out 44 is not going to be a perfect square. It gives us a rough decimal. So we say then we have two real irrational roots. And there you go. That's the use of the discriminant in the quadratic formula.